Today we will be discussing digital storytelling for mathematics, teaching whole numbers, rational numbers, and integers. This will be discussed in terms of teaching literacy in mathematics, which involves learning vocabulary in order to understand what is meant in the reading problems. According to the Texas Essential Knowledge and Skills, one of the focus areas, according to 6.2a, is that we must classify numbers, integers, and rational numbers using representation. The representation is visual, such as Venn diagrams as listed below, to describe relationships between sets of numbers. To start, we will need to make sure that the students understand the definition of whole numbers and integers. So to start this lesson, I will ask my students if they understand what the words mean, and give them a chance to define it on their own. This will activate prior knowledge. Okay, class, today we will be discussing whole numbers, integers, and rational numbers. Let's begin. Can anybody tell me? Okay, class, today we will be discussing whole numbers, integers, and rational numbers. Miss H, isn't a whole number like just a number? Janet, that is very close, but it is not quite. Janet, that is very close, but it is not quite what I was looking for. If y'all direct y'all attention to the board, we can discuss what a whole number is a set of counting or natural numbers and zero. This would be 0, 1, 2, 3, and 4. Those are all examples. An integer is a number that is written as a whole number, or a set of numbers, that can have a positive or negative value. An example of this would be 2, 456, and negative 18. A rational number is any number or set of numbers that can be written as a fraction, where both the numerator and the denominator is a whole number. An example of this would be 4/5 or negative 2/3. But here's a little key fun fact for you. Some decimals can be rational numbers, but as the decimal does not have a way to be written as a fraction, it cannot be a rational number. Let's take, for instance, 0.13. Is that a rational number? Jen, Sage, I would probably say yes, but I really don't know the reason why. Well, Janet, that is a good response. It is a rational number, but the reason being because 0.13 is 13 over 100 as a fraction, so it is considered a rational number. Can anyone guess, is pi or 3.1415, etc. a rational number? Donovan? No, Ms. H, I don't think it's a rational number because it's always going, so there's no way of knowing it. Donovan, that is correct. It isn't because it cannot be written as a fraction. Because it is a continuous number, we do not know what number we would put it over. The 13 goes over 100 because it's in the 100th place on the decimals for 0.13. But 3.1415, etc. does not have an ending point, so we do not know how to write that as a fraction. Okay, class, let's take this image. Can anyone tell me what x could possibly be? Let's go with Jasmine. Is it just a number? Well, that is close. X can be any whole amount, a positive or negative, because X is in both rational and integer, and it has to be a whole number, a whole value. So X cannot be any value that is already expressed as part of a whole. For example, a fraction or a decimal. It has to be a whole value. Okay, class. Now let's take a look at these four numbers, and I want to see if you'll be able to tell me what these numbers are considered. Let's begin with 12.3. Can anyone tell me what they believe this number is? Jake? Is it a rational number? That is correct. It is a rational number. Because it is part of a whole, we know it cannot be an integer. And we know it can also not be a whole number. But it is a rational number because it can be written as a fraction. Now, anybody tell me what negative 23 would be considered? Let's go with Jasmine. Jasmine, what would you consider negative 23? Would it be a whole number? No, not quite. Would you like to take another guess? An integer? That is correct. It would be an integer because it is a negative form of a whole number. So it cannot be a whole number because whole numbers are not able to be negative. The next one, 47 over 1,000. Can anyone tell me what this number might be? Donovan? Yeah, probably a rational number. That is correct, Donovan. It would be a rational number because it is written as a fraction, so we know it can be written as a fraction. Good job. Now the tricky one. Can anybody tell me what 0 is? Let's see. Jasmine? Miss H, wouldn't that be a whole number? That is correct, Jasmine. It is a whole number because 0 is considered to be a counting number or a natural number. So it would be a whole number. This concludes my lesson example. It is a method I use based off a site called Math for Texas, helping parents understand the math standards. Within this standard, it is apparent that students need to understand the definition of what these words mean. And without understanding these definitions, students will not be able to be literate in mathematic reading. I believe that not every teaching method of vocabulary needs to be complex or done by just defining the term. In order to teach proper literacy for mathematics, we need to make sure that our students retain the information and understand the words completely. And this is done by examples. I really enjoyed doing this story for you, and I really do hope that it'll help you and your students in the future. Thank you.